Okay, my friends. So we've looked at, let's see, bar graphs, histograms, which are very, very similar, and line charts, which are also very similar. All three of those actually are the same kind of graph, actually just viewed with three slight tweaks to them. In all of those, you've got a horizontal axis and a vertical axis. So you've got really two pieces of information at any given point on the graph. This part three, the last graph I want to look at, and we'll add more as we go through the course, but this is a good start, are pie charts. And I think these are a very intuitive one, I think, for a lot of people, because people like pie charts. They seem intuitive to them. Plus, it's a circle, which is kind of a nice shape. A pie chart is great when you've got a total of something that is broken into parts. So it's literally percentages. So it's a visual of percentages. So this is a little bit of research I did. Where does Oregon get its electricity from? I was always under the impression that most of it came from hydroelectric, which means you have big dams. And those dams back up water, and then the water is fed through turbines, which turn because of the water pushing against them, and then the turning creates electricity. And I was right, kind of, in that 39% of our electricity comes from those. But that's only 39%. Where does the rest of it come from? And then you start doing the deep dive, and you get some from natural gas, some from coal, a lot of chunks of those. Wind power, if you're ever driving around. It's generally up by the Columbia River Gorge, I believe. You'll see windmills up there because it's very windy. Nuclear, which I didn't even know we had nuclear plants in Oregon, but I guess we do. Or maybe the plants are somewhere else and we just get the power across the state line. I don't actually know the answer to that. And then others. Others could be anything from biomass. Sometimes they harness the heat that is given off at like a dump site. Geothermal. You can sink a well super far down, and the further down you get, the warmer it gets. And if you get down far enough, and it gets warm enough, you can turn turbines that way, and that's actually pretty good around a volcanic area like Oregon has. So there you go. Let's use this pie chart to talk. Oh, we just got ahead of myself here. From which source does Oregon generate most of its electricity? Well, we answered that. It's hydroelectric because it's got the biggest slice, 39% of the entire circle. About 90% of all Oregon's electricity comes from what three sources? Well, it looks like hydro, coal, and natural gas. I'm going to check that real quick. So 39 plus 26 and a half plus 21 and a half. I add those up, carry the 1, 17, carry the 1 plus 3 is 4, 87%. Yeah, that's about 90%. So 87% comes from those three sources. It probably would have been easier if I had just gone the other way and added up these three and subtracted it from 100. So 6 plus 7 is 13, from 100 is 87. That would have been quicker, but whatever. Give one thing this pie chart doesn't tell you. Okay, well, I'm going to let you think about that for a second. What doesn't it tell you? Well, I mentioned one thing. It doesn't tell us what others is, right? What does others mean? Does it mean what is included in others? That's one thing it doesn't tell you. But something else it doesn't tell you. It tells you that 39% of all Oregon's power is hydroelectric. But what it doesn't tell you is how much power is that actually? Yeah, it's 39% of all. So 39 out of every 100 units of power are hydro. But how many total units of power are there? Well, I did some more digging, and I figured it out. 50 terawatt hours. Now, you might remember in class, we talked in class about something called a kilowatt hour. A kilowatt hour. Kilowatt means 1,000, or kilowatt means 1,000 watts. The next thing up from kilo is megawatt. A megawatt is 1,000,000 watts. The next thing up from megawatts is gigawatts. That's 1,000,000,000 watts. The next thing up from gigawatts is terawatts. That's 1,000,000,000,000 watts. So Oregon uses each year about 50 trillion watt hours of electricity. I'm trying to figure out how to make this make sense. Imagine 10 100-watt light bulbs on. Holy crap, I gotta think about this. 10 100-watt light bulbs on. No, you know what? I'm not even gonna try. It's just, that's the number. 50 The unit is, it's almost impossible to understand how big that number is. So, and I'm not going to be able to do it through a video. If I had time in class with you, I'd be able to do it. But the number 50 terawatt hours, that is the unit, terawatt hours. So then we just talked about what it actually is. How many terawatt hours were created by hydroelectric dams? Well, again, we know that 39% of it was created. So all we have to do is figure out what is 39% of 50. And that is 19.5 terawatt hours. I wonder if we can actually put, will it be able to deal with this? Let's try to tell. Nope. See, this is the kind of thing Google doesn't do well. I warned you about this. Google does certain conversions great, and sometimes it gets confused. So this time I'm asking it to do 39% of 50 terawatt hours, and it changes it to joules, which is the metric measure for power. So ignore it. Just do 39% of 50, and then realize that 19.5 has the unit terawatt hours at the end of it. I love it when you break Google. So much fun. How about coal plants? So coal plants is 26.5. So we can just go back into the search window, wherever I just was. I don't even know. We'll just do it here. 26.5% of 50 terawatt hours. And that's going to be 13.25. I'm just curious. I can't help but be interested in how we can train Google maybe to. Nope, it wants to change it to joules. So we just have to know that it's terawatt hours, 26.5% of 50, and that's 13.25 terawatt hours of power. And last but not least, wind farms, which is the 7% that's down here. And we just go back one more time to our little calculator. There's a couple ways you can do this one, actually. You can figure out what 1% is and multiply it by 7, or just do 7% of 50 and get the 3.5 that it's going to be. So 3.5 terawatt hours. The clever among you will realize that since the number is 50, you can just take half of the percentage, drop the percent sign, and that's the answer. So half of 7 is 3.5. Half of 20. I'm not even gonna talk about that. That's I don't like shortcuts are great if you see them, but if you don't see them, sometimes they actually seem like magic, and I don't want math to seem like magic. Okay, that, my dear friends, I believe brings us to, it does. Oh no, it didn't. No, it didn't. Yes, it did. We are now finished. That was number 42. So I hope that helps you. And this way, when we come back on next week, week 7, we can rock right into that next lab, which involves R2-D2 and the game Trouble and how to look at hypotheses and statistics. All right. Take care of yourselves. See you soon.